So hi everyone, this is the 6th lesson. Today we're gonna implement our first baseline model, and we're only for classification. In the next video we're gonna learn how to create baseline models from scratch for linear regression, for just regression. And we're gonna learn how to use baseline models in the real life, how to use them from libraries and what they're created for. So beginning from zero knowledge in machine learning, what baseline models are? They are created for us to be able to compare our complicated model like neural networks to simplest, dumbest models that always return just one value. Because if when we classificate, for example, numbers 0 and 1 to classes, and if our, for example, neural network gets 10% of all the values correctly, predicts 10% of all of them correctly, and if we just return the mode value, it would be 30% correct. So why would we exactly use neural networks that are just useless and more complicated than baseline models? So we would just understand that our complicated model is just worthless. Let's just load the dataset and a few libraries that we need. Pandas SPDs we always do from scikit-learn. The datasets we import. Don't exactly remember. What breast cancer, like that. From scikit-learn model selection, import accuracy score. No, not accuracy score. We're gonna import train test split, and from scikit-learn matrix, so we're gonna import accuracy. Accuracy score, like that. I'm gonna teach you what all the values stand for, but firstly let's load our dataset. Load equals like that. We're also gonna print load keys. Data. Let's form our dataset and the target. Data equals, no, let's say like ds, short for dataset. Let's say pd.data frame, like that. Load data and columns. Explicitly we're saying that. Feature names, like that. Alright, let's see how it looks. ds that had that. Something's wrong. Index must be called with the collection of some file. Feature names, I'm sorry, like that. An obvious mistake. Like that. So we see all of the data. So we have a lot of features, so-called features, and we're also gonna look on how the target value looks. Let's see T, short for target value. Let's say that load.target and see how it looks like that. So what our baseline model for regression would just look like. It would just return the mode value of it, and we're gonna estimate how bad or great the percent of the percent of the correctly predicted value as, the proportion how high or low that is. So if we're gonna create our model, it's gonna be a class. Let's call it dummy classificator, pretending like we're smart enough. We need two methods, one for feeding a model, for teaching it data. Oh no, I have forgot an important thing. You should always remember that every time you are trying to create a model, you need to separate your data for testing and for training. So we're gonna say that ds.train ds.test tv.train and tv.test equals, and we, as you remember, we loaded this function, this function, train test split, so it's actually created like that. We're gonna pass dc and then tv, and then we're gonna say the test size like that, 0.33. So we're gonna test it with 1/3 from our data. And random state, let's say 9, it's created for you if you copied my code to get the same values I would get. Like that. So we have now train data, train target, and testing data and testing target. So we may actually start creating our data set. Dummy classificator, like that. First method is fed to teach the model our data self. X that can be none, Y that can not be none. So let's say that we need the mode value, and I'm gonna check, do we actually have in statistics from statistics import mode? Can we do that? Yeah, we can actually do that. So let's say from statistics import mode, we're gonna say self.mode equals mode from Y, and then return self. And the second thing we're gonna use as def predict for data prediction, self and X that can be actually none. And the important thing is that we want to return the same amount of targets as the number of objects in our data set. So for one object comes one class. So we cannot just say return self mode. Obviously we want to return the array that is full of self mode. So obviously we're gonna say, not obviously, I mean this thought should be not really complicated for you, and then we're gonna implement that with np.fol. Firstly, the length of the array, so length of X, and actually we cannot just say like that, length of X, and we're gonna follow it with self mode, like that. I hope parameter a default follows, we don't care. Yeah, so what we do, we say no, we have just used DC for dummy classificator. It's gonna be our dummy classificator. dc.fetch with our ds train and TV train. Sorry, like that. It's gonna work. Yeah, it worked. And then we're gonna predict with DC test, and it doesn't work. So what's the problem? I forgot to import numpy as in p. So now it's gonna work. Yeah, it works. As you may see that we have the mode value. And how do we estimate the proportion of what's correct? We just say accuracy score that we have used, this thing, DC predict, and we're gonna compare it to TV test because those are actually answers. So I have 61%, that's actually not pretty bad. And then one important thing that about how to implement a baseline model and from scikit-learn, because obviously in your life you're not gonna write so much code from just a simple model. Dummy import dummy classifier, like that. And currently we're gonna see that new, for example, new DC equals this thing, and what, and strategy, we can say mode, because we've created that with mode, because we may use different strategies that we're gonna talk about later. And just to check everything works correctly, it works correctly. Just see new dc.fetch. What did we feed that with like that DSC train, TV train. Does it work? A strategy parameter must be a string. Most frequent, yeah, we missed that. Like that, so we have our model that then looks different, and we can print accuracy score from this thing to our TV test thing. And the white true parameter of accuracy score must be an array like our sparse matrix. Predict. I'm sorry. I used a wrong script. New DC like that, and those are the same values. So now you can use the dummy classifier with the most frequent strategy. And we may also, for example, check what we can use. For example, prior. What would you get if we used prior? 6-2. Oh, the same thing actually. Don't see a problem, but alright. Just the same as most frequent. Yeah, so like that. And in the next lesson we're going to talk about how to actually implement the same thing for regression, for the model that predicts a value instead of a class. Instead of 1 or 0, like red or blue, we're gonna predict, for example, a price or something. So this video is a bit long, and I hope everything is understandable, and write what you think in comments.